Welcome. Let's take a look at a differentiation strategy known as logarithmic differentiation. This technique can do one of two things. In one sense, it can help us find the derivative of functions that we don't already have techniques for differentiating, and we'll see that in a moment. Or it can simplify the process of finding some derivatives that we already have rules for. So with logarithmic differentiation, here's kind of the big idea, the general strategy. Our goal is to find dy dx, or the rate of change of y with respect to x. So what we do is we take the logarithm of both sides of the equation, and we use the properties of logarithms to help simplify the process of differentiation. Once we've used the logarithm properties, we then apply appropriate rules of differentiation to both sides of the equation. Implicit differentiation is the means by which we do this. And then we use algebraic techniques to solve for dy dx and replace any instances of y in dy dx with the original definition of y. So let's go ahead and see how this works. So we're going to see how logarithmic differentiation will work on a couple of examples. And what I want you to notice at first is that with these examples, we have a base that involves the variable, and we have an exponent that involves the variable. And in cases like this, we don't yet have a rule that will allow us to deal with the variable being in both the base and in the exponent. We have a rule that helps us deal with the variable being in the base, and that's the power rule. And so we would have n times x to the n minus 1. We have a rule that allows us to deal with the variable in the exponent. So this would be the natural log of b times b to the x power. But we don't have a rule that helps us with the case where the variable is in both places. So we're going to use logarithms and logarithmic differentiation to help us do this, to find these derivatives. So we're going to start by taking the logarithm of both sides of the equation. So we'll have the natural log of y equals the natural log of the quantity 1 plus x raised to the 1 over x power. And then one of the properties of logarithms is that this exponent can become a multiplier. It can come out front of the logarithm. So we would end up with the natural log of y equals 1 over x times the natural log of 1 plus x. And we're almost ready to find the derivative. We'll go ahead and rewrite this 1 over x as x to the negative 1 power so that it's ready for us to find the derivative. So x to the negative 1 power times the natural log of 1 plus x. Now at this point, we can go ahead and use implicit differentiation. And while we do that, we will also be cognizant of, on the right-hand side, we have to use the product rule. And we will also need to be aware of where we need to use the chain rule. So taking the derivative with respect to x on the left side of the equation, and the derivative with respect to x on the right-hand side of the equation. Okay, now differentiating implicitly. On the left-hand side of the equation, we will have 1 over y. The derivative of a function is 1 over the function times the derivative of the argument, so we'll have a dy dx there, equals, on the left-hand side, we're going to have to use the product rule. So we'll have the derivative of x to the negative 1 power, our first factor, times the natural log of 1 plus x, plus the derivative of our second factor, natural log of 1 plus x, times our first factor, which was x to the negative 1 power. So now we have 1 over y times dy dx equals, now our derivative of x to the negative 1 power is negative 1x to the negative 2 times the natural log of 1 plus x, plus, and now our derivative of the natural log of 1 plus x is going to be 1 over our argument, so 1 over 1 plus x, times the derivative of our argument, and the derivative of 1 plus x is simply 1, times x to the negative 1 power. At this point, let's go ahead and multiply both sides of our equation by y. So on the left-hand side, y times 1 over y, that's going to give us a 1. And so we have dy dx equals, and now this negative 1 over negative 1x to the negative 2, we're going to write that as negative 1 over x squared times the natural log of 1 plus x, plus, and then we have an x to the negative 1 power in our second term. So we're going to write this as 1 over 1 plus x times 1 over x. And then we're multiplying that by y. Now, at this point, we want to replace y with its original definition. So our derivative here is dy dx is equal to multiplying negative 1 over x squared times the natural log of 1 plus x. We'll have negative natural log of 1 plus x all over x squared, plus, and then multiplying the 1 over 1 plus x and the 1 over x. We get 1 over 1 plus x times x, and then multiply by y, and we get that being 1 plus x to the 1 over x power. Now there's not much we can do to simplify any part of that derivative, so we leave it alone. And that would be our derivative of our original function y. Let's take a look at our second example. We've got y equals x to the 2 over x power. So again, variable in both the base and in the exponent, so we'll apply a natural logarithm to both sides of the equation. So the natural log of y equals the natural log of x raised to the 2 over x power. We'll go ahead and use that exponent property within logarithms to bring the 2 over x as a factor in front of the logarithm. So we'll have the natural log of y equals 2 over x times ln of x. And then let's rewrite that 2 over x in preparation for the derivative. So ln of y equals 2 times x to the negative 1 power times the natural log of x. At this point, we're ready to find our derivative. So we're going to use implicit differentiation, and we'll take the derivative with respect to x on the left side of the equation. So derivative with respect to x of natural log of y equals the derivative with respect to x of 2x to the negative 1 power times the natural log of x. And on the left-hand side, our derivative of the natural log of y is going to give us 1 over y times dy dx by the chain rule. And on the right-hand side, we'll need to use the product rule. So we'll have the derivative of our first function, that's 2x to the negative 1. So its derivative is 2 times negative 1x to the negative 2 power. So that's the derivative of the first function times the second function, which is ln of x, plus the derivative of the natural log of x is 1 over x, times our first function, which was 2x to the negative 1 power. At this point, let's go ahead and multiply both sides of the equation by y. And when I do that, I need to apply it to the whole right-hand side, so we'll put brackets around that. And on the left-hand side, y times 1 over y is going to give us a 1. So 1 times dy dx is dy dx equals, and let's see, we have 2 times negative 1 x to the negative 2 power. So we're going to have a negative 2 over x squared times the natural log of x plus 1 over x times, and then we have 2 times x to the negative 1, so that's 2 over x. And all of this will be multiplied by y. Now keep in mind that our y for this particular example was y is x to the 2 over x power. So we will be replacing y with x raised to the 2 over x power. So our dy dx is equal to negative 2 times the natural log of x over x squared plus 2 over x squared times y, and y is x to the 2 over x. And there's our derivative. I hope you find this helpful.